everybody, this is our lesson on the tangent ratio. The tangent is one of those trigonometric ratios. We've got cosine, sine, and tangent. So we're going to be focusing in on tangent in this lesson. It's one of those great tools that helps you find missing sides and angles in your triangles. So we'll get started. You need to know when you're working with tangent that it is going to be developed from the opposite side over the adjacent. It's the relationship of opposite to adjacent from a reference angle in a right triangle. So if you're looking at a right triangle and you pinpoint a reference angle, for instance C, the one that's labeled here, you'll need to find the opposite side, which is the side across from the angle C, and divide that by the adjacent side, which is the side attached to C. So it's both of the legs of the triangle, not the hypotenuse. Now the other side that we haven't looked at in this one is the hypotenuse. We don't need it for tangent, but you do need to know where it's located. It's that other longest side of your triangle. Alright, so let's practice. Let's say we'd like to find the tangent of angle A in this triangle below. So it's very important when they tell you to find tangent or cosine or sine of an angle, go find the angle first, because that's what's going to determine where your opposite and adjacent and hypotenuse sides are. So tangent of angle A, we have found angle A, we want the opposite over the adjacent. So we want to go across from A, so we're looking at 4. Divide that by this side here, the side attached, adjacent, which is 10. So tan, we can abbreviate, of A is 4 over 10. We don't want to leave it like that because that can be reduced. You always want to be on the lookout for that. You can reduce that to 2 over 5. And we have found the tangent of A. Now you can also use this tangent to help you find the actual angle measure if you need to. And the way you're going to do that is to use the inverse tangent. It's a operation on your calculator. If you look at your calculator and you find the tangent, TAN button, it should be sitting above that button, and it looks like tan raised to the -1. It's called tan inverse operation. You can access that by using the second key, usually on your calculator. That second button will allow you to access the things that are above your normal keys. So you can try that out as we're working along here. So let's say we want to find the measure of angle A. So identify where angle A is located. He's here. And normally, for regular tan, like we found before, the tan of A, remember, was 4 over 10. Opposite over adjacent. We found that in that earlier slide. So if I needed to know just A, just the measure of A, I would need to isolate A and get A by itself in this equation here. So the way you want to do that is to use inverse tan, like we mentioned. Tan inverse operation is going to sort of undo that tan operation for you to get A all alone. So you want to use that on both sides because that's what we are going to do in equations. We're always going to do the same thing to both sides, whatever operation we decide. So tan inverse of tan is going to leave A by itself for me. And I'm just going to type in tan inverse of 4 over 10 over on this side. So you check that out, type it in, see if you come out with the same value. When I calculated mine, I got 21.8 degrees. You want to make sure your calculator is in degree mode as well. Alright, so we talked about tangent, what the pieces of the ratio are. We talked about how to use it to find angles. Now let's look at similar triangles and their relationship to tangent. If we have similar triangles, we know that we have proportional sides, meaning the sides have a special relationship with each corresponding side in the two triangles. They have the same ratio when you compare. And we also know that the angles are the same exact angle measures for the corresponding angles. For instance, if these two triangles were similar, then these corresponding angles would be exactly the same measure. And any two corresponding sides should have the same relationship as any two other corresponding sides. So we're going to test that out. using tangent, we're just going to pick out an angle here. We're going to see if that is true for this triangle. So let's just label an A and an A prime here, just to call it something. This angle here, these corresponding angles. And let's compare the tangent ratios of A. So what we need is we need the opposite and adjacent for each one. Let's just see what we get. So if we put tangent of angle A here, we have 4/3. If we find the tangent of A prime in this second triangle, we have 6/4.5. Just want to type both of these in, see what we get. If we get the same number, then that means they have the same relationship, and we do. 1.3 repeating. And if we know that all of the sides, the corresponding sides, follow suit here with this same relationship, then we are dealing with similar triangles. Because you notice they're not the same size, but if they have proportional sides and same angles, then they're similar. So what can we conclude about what we just saw? What can we conclude about the tangent values of congruent angles in similar triangles? We were dealing with similar triangles earlier, and we saw that the tangent values of the angles were the same. And that will always be the case. So this concludes our lesson on the tangent ratio.